Is it recording? Okay, welcome to Success Jamb class. Today is our first day of meeting and we'll be looking at chemistry. Now, the main aim of this class, of course, is to ensure that our students excel in their Jamb. We're not looking for a mediocre score, we want an excellent score. So we're doing all it takes to make sure that that's achieved. So this video is a video of our first class, so that those that can't make it to the class physically can also join us online. And if you want to pass Jamb, there's one thing you should get first. You cannot pass Jamb without your past exam question. I will recommend this checkpoint. It contains all your courses: English, use of English, mathematics, biology, physics, and chemistry. All your courses are inside here. Checkpoint. So today we're looking at chemistry. And before I even teach any subject, I'd like to know the level of our students here. So I'll be giving 5 random questions from one of the years in chemistry. Everybody write down. You write this question down. I want to see the level of the student so I will know where to reach you. So online students, join us too. This is our first chemistry class. I want to give 5 random chemistry questions. This one came out, Jamb Chemistry 2009, question 15. Everybody write this question down. If 10.5 gram of lead 2 triosonite if, please online students, come with us. I'll write on the board so you can write. If 10.5 gram of lead 2 trioxonitrates 5 is dissolved in 20 cm cube of distilled water, at 18 degrees Celsius, the solubility of the solutes in mole per dm cube is, as usual, since we are dealing with Jamb, you'll be given options. Option A, 1.60. Option B, 5.25. Option C, 16.00. Option D, 525.00. This is the first question that was given in Jamb Chemistry 2009, question 15. Like I said, I want to use these 5 questions to check the level of the students so that we can brush up. Also, as a friend us online, if you can't answer these questions, it means that you have work to do. So you join us. This video will be posted for everybody so you can have an idea. Some of you have not registered yet, I believe, because you want to see first. Seeing is believing. So this video will be uploaded for everybody in the Jamb group so that you can see how the class is going to look like. You can see how clear it is. A lot of things I've been put into this to make this class clear like this. So this is how the class is going to be. So currently now we're going to solve this, but we have 5 questions. Question 2. Question 2 said the percentage, everybody write down, of water of crystallization in ZnSO4.7H2O is A, 33%, B, 44%, C, 55%, D, 87%. And they gave us some hints. They said take Zn as 65, take S as 32, take O as 16, take H as 1. This is another question. The percentage of water of crystallization in ZnSO4.782 is, these are the options. Another question. Are we there, class? Another question. We have two questions on the board. Question 1 and question 2. Another question. 0.0075 mole of calcium triazocarbonate 4. 0.0075 mole. 0.0075 mole. Question 3. Let me write it here. 0.0075 mole of calcium trioxocarbonate 4 is added to 0.015 mole of a solution of hydrochloric acid. The volume of gas evolved at STP is A, 224 cm cube, B, 168 cm cube, C, 112 cm cube, D, 100 cm. Now they give us a hint here. Molar volume of gas at STP equals 22.4 dm cube. Molar volume of gas at STP equals 22.4 dm cube. Online viewers, make sure you're writing. Now let's take these three questions first. I believe you have had enough time to write, so I'll need to clean the board so I can solve question 1 first before going to question 2 and question 3. Have you written the three questions? I can clean this one. Please try to be writing fast. So we have 3 standard Jamb questions here. Now, let's look at the first question. If 10.5 gram of lead 2 triazonitrate is dissolved, were we given any parameter about lead? Yeah, they gave us lead as 207. Did I give you that? In the question, did I give you this lead? Class, did I give you this? Lead 207, nitrogen 14, and oxygen 16. Please add this. Please add this. So class, let us solve. We are told that if 10.5 gram of lead 2 triazonitrate 5 class Lead 2 triazonitrate is PbNO3. Now, this is PbNO3 class. Lead 2 triazonitrate 5 is PbNO3 2. It's dissolved in 20 cm. So mass of this, the mass of this is 10.5 gram. It dissolved in 20 cm cube. So volume is 20 cm cube. Volume is 20 cm cube of distilled water at temperature 18 degrees Celsius. We have to find the solubility of the solute in mole per dm cube. Class, one short question that comes out every year in Jamb is solubility. In this Jamb class, we're taking short exam topics. There are some topics that you can't escape in Jamb chemistry. You can't escape them in Jamb chemistry. One of them is solubility. And there's a general formula to solve for solubility. Class. So in this class, we don't waste time with unnecessary topics. We hit the nail on the head so you can clear your Jamb. Now, solubility. What's solubility? Of course, solubility is when you have a solute dissolved in a solvent. For example, when you put salt in water, the salt dissolves in the water, right? And you can be asked to calculate the solubility. Solubility simply means concentration of that salt in the water is the solubility. That's why you notice that solubility and concentration have the same unit, mole per dm. This unit here is also the unit for concentration, also the unit for solubility, mole per dm cube. So when someone says you find solubility, they also asking you to find the concentration of the salt in the solvent. For class, for a solution contains, there are two things that makes up a solution. We have solutes plus solvent, plus what? The solute is the salt. The solvent is the liquid that the salt dissolves in. For example, water. We all know that water is a universal solvent, right? For example, the solvent in this question is distilled water, and the solute is lead 2 triazonitrate 5. So 10.5 gram of lead 2 triazonitrate 5 is dissolved in 20 cm cube of distilled water at 18 degrees Celsius. Class, to solve for solubility, we are going to say the given mass all over the molar mass all over the what? Molar mass multiplied by the given volume. The given what? Volume all over the standard volume. Given mass all over the molar mass equals to the given volume all over the standard volume. Standard volume we use 1000 cm cube. 1000 what? Cm cube. Plus the given mass is 10.5 gram. We need to find the molar mass of PbNO32. The molar mass of PbNO32. Pb is 207. N in this bracket is 14. You can see 14. Oxygen is 16, but we have 3 oxygen. 16 times 3 is 48. All multiplied by 2 because of the 2 outside the bracket. So if you see N is 14, but oxygen is 16, right? But we have 3 oxygen, so 16 times 3 is 48. So we have 207 plus 14 plus 48 looks like 62. 60 what? 62 multiplied by 2 looks like 124, right? 207 plus 1, 2. What is 207 plus 124? This looks like 331, 331 gram per mole. So the molar mass of PbNO32 is 331 gram per mole. Now, the given volume in the question is 20 cm cube. Standard volume is 1000. Standard volume is 1000. Standard volume is 1000. Who is the calculator there? So we're going to say Class, sorry, I made a mistake in the calculation, this formula for solubility. We are giving mass times molar mass, giving mass divided by molar mass, multiplied by the standard volume, which is 1,000, all over the given volume, all over the given volume. Given mass over molar mass, multiplied by 1,000, all over the given volume. So class, 1,000 is supposed to be up, and the given volume is supposed to be down. So that 1,000 up is the standard volume. The given volume is 1 down. So we're supposed to say our given volume is what? Our given volume in 20 cm cube of distilled water, right? These are given in 20 cm cube of distilled water. So we're going to say 10.5 multiplied by 1,000 will give us 10500 divided by 331 times 20 will give us 662. Now 10,500 divided by 6620 will give us 1.586, which if you approximate, you should have 1.60. Approximate to 2 decimal place, and that's option A. That's option A. So class, please take note the formula for solubility is given mass over molar mass multiplied by 1,000 divided by the given volume. 1,000 is standard volume divided by the given. The given volume is one that you give in the question, 20 cm cube of distilled water, given volume of the solvent. This is the mass, given mass. Given mass is 10.5. The molar mass you won't be given, you have to find it. Look at the molar mass. How did we find it? Now, note in the question, they did not even tell you that this is PbNO32. You must be good in chemistry to know that lead 2 triazonitrile is PbNO32. I'll teach you how to demystify chemical compounds to get their chemical formula. We together? Yes, I know this lead. Lead is Pb. Lead 2 means that this is the 2. Triazonitrate means 3 oxygen. Trioxo. Nitrate, nitrogen. Triazonitrate, 2. Lead 2, triazonitrate 5. Yes. Why is this nitrate 5? Because if you check for the oxidation number of nitrogen in this compound is 5. Is what? So write down and let's go to the second question. So you can see how it took to solve a standard Jamb exam question. So you time yourself. That's why I told you to get Jamb pass questions. So time your and work on your discipline before the exam. So we'll be training you in this class. Work on your discipline, time yourself so you can solve in record time. Yes, someone just asked what of the temperature class. This has been one mystery that we've yet to unravel when solving solubility because you'll be given temperature. One mistake most of them make is that they think that every quantity they give them in a formula, you must use it. No. It's not everything they give you in a question you must use. Some parameters you are given in the question is to confuse you or to distract you from the main solving. Are we together? Yeah, the temperature is just telling us that class, all salts are soluble at a particular temperature. Solubility is dependent on temperature. So class, a salt can be soluble at a particular temperature, but if you reduce the temperature, it's no longer soluble. Do you understand? So this is just an information. You're not to use it. Good question. Now let's go to the second question. Let's go to the second question. See, just by solving one question, we have talked about solubility. We have talked about this compound, molar mass. This is how you prepare for Jamb. Just by taking one question, you've touched different things in one question. Okay, since question 3 is on the board, can we just take question 3 so that we'll just solve it like this? Since it's already on the board, let's just solve it beside. So that when we now know there's 2, we'll write again. So class, this question 3 said 0.0075 mole of calcium triazocarbonate 4. See, Jamb is testing you. It's added. It means it's reacted. Calcium triazocarbonate 4 is CaCO3. You do not need to start thinking of what's calcium triazocarbonate 4 in the exam. So you have to prepare yourself before the exam day. It's added, reacted, right? Added means reacted, right? To 0.015 mole of the solution of hydrochloric acid. Is added to what? 0.015 mole of the solution of hydrochloric acid. What is hydrochloric acid? HCl. Now in this reaction, the volume of gas evolved. So it means the gas is evolved after the reaction, right? It's our job to write a balanced equation involving this. An experienced chemistry student knows that you have to balance this equation. Calcium will pick chlorine and form CaCl2. And we're going to have plus H2O plus CO2 class. Anytime a transcarbonate reacts with an acid, the CO2 is what? Liberated. CO2 is what? Liberated. So this gas, we have to find the volume of this gas evolved. Class, they gave us 0.0075 mole of CaCO3 and 0.015 mole of HCl. So looking at the question we need to do, which of these reactants, class, this question will allow me to teach you what we call limiting reagents. Because the question we need to ask ourselves now is, which of these reactants will determine the volume of gas evolved? Which of these reactants will determine the volume of gas evolved? All right, so we're giving you enough time to write. Check it, is it recording? We're giving you enough time to write. Class, this question will allow me to teach you every question I give you in your Jamb. That's a get Jamb persistence. I will use Jamb persistence to train you in Jamb. Because anything that comes out in Jamb persistence is important to Jamb. You understand? Any question that comes out in Jamb exam is important to. So I will use the Jamb persistence to train you in the topics that are important. Because if you carry the whole Jamb syllabus, you might not finish it before this, right, Jamb? Thank God they started registration already, right? Meaning that I was nice to see they were doing registration. And when we finish the whole chemistry Jamb, no math, physics, and not everything will come out. How many questions came out in Jamb last year? 40? 40 questions. So in the whole Jamb, SS1, SS2, SS3, only 40 questions. Meaning that question cannot come from everywhere. You need direction. That's why we're in this class. That's why you need class like this. You need what? Direction. So the best place to get direction is the Jamb exam question they've set in previous sets. You study it, teaching you step by step. This question now will allow me to teach you what we call limiting reagent. Write down how to determine limiting reagent. Limiting what? Reagents. Limiting reagents. Limiting reagents. When two reactants react, not the two of them do not finish at the same time. One finish before the other. One finish before the. That reactant that is first consumed is known as the limiting reagent. That reactant that is first used up is known as the limiting. So the limiting reagents is the reactant that is first used up during a chemical reaction. During a chemical reaction, the reactant that is first used up is known as the limiting reagent. When you go to market, you buy rice, you buy beans. Notice your rice and beans don't finish at the same time, right? One finish before the. If you buy provisions, milk and Milo. Milk and what? Milo. Which one is to finish first? I think it's milk, right? Depending on the one you like. So when two reactants are reacting, one of the reactants is still remaining while one has finished, right? That reactant that has finished
is the limiting reagent. Now, what's the importance? So, we are writing your notes. A limiting reagent is the reactant that is first used up or consumed during a chemical reaction. Is the reactant that is first used up or consumed during a chemical reaction. During what? A chemical reaction. The reactant that is first used up or consumed during a chemical reaction. What is the importance of the limiting reagent? Class, the limiting reagent is so important because it is the limiting reagent that determines the amount of product that will be formed. It is the limiting reagent that determines the amount of product that will be what? Formed. Because as soon as the one of these reactants is finished, the reaction stops. A reaction ceases to continue as soon as one of the reactants is no longer available. The reaction stops. So who finishes first determines how many of these people will be formed, right? Because as it finished, these people stop being produced, right? As soon as any of the reactants finish, the product stop being produced because the reaction will stop. And so the limiting reagent, rather note that the limiting reagent determines the maximum amount of product that can be obtained in a chemical reaction. Note, the limiting reagent determines the maximum amount of products that can be obtained in a chemical reaction. Determines the maximum amount of products that can be obtained in a chemical reaction. The limiting reagent determines the maximum amount of product that can be obtained in a chemical reaction. Now, this question requires, before you can get the volume of gas evolved, we must first understand which of these persons will determine the volume of gas evolved. Is the person that is the limiting reagent. I'm trying to explain to you why I'm going this far to teach you all these things. You see that this is one question, but we're learning. The other one we learned, so that's how we're doing. Now, limiting reagent is the reactant that is first used up or consumed during a chemical reaction. Note, the limiting reagent determines the maximum amount of product that can be obtained in a chemical reaction. Now, how to determine limiting reagent? Right now, how do you determine the limiting reagent? How do we determine who will finish first? Like, there's a step you can use to determine the reactant that will finish first. Class, the reactant that will be first consumed is the reactant with the least number of moles. Is the reactant with what? Least number of moles. But class, before we conclude on that, someone should help me. What's 0.015 divided by 2? Give me. Because they say 0.0075 mole of this reacted with 0.0015 mole of this. From the balanced equation, it is 1 mole of CaCO3 that reacted with 2 mole of HCl. It is 1 mole of this that reacted with 2 mole of this. Now, they already gave us the number of moles. The molar mass of CaCO3 is 100 grams. It's what? 100 grams per mole. How do I know that? Calcium is 40. Carbon is 12. The atomic mass of carbon is 12. Oxygen is 16. 16 times 3. 48. If you add 40 plus 12 plus 48, you're going to have 100. You're going to have what? HCl. H is 1. Chlorine is 35.5. That's 36.5 gram per mole. Now, looking at this question critically, you're going to see that the mass of this guy, because number of moles equals to mass divided by the molar mass. number of moles equals to mass all over molar mass. But we have number of moles already as 0.0075. We don't know which is the mass, but molar mass is what? 100 for this. And number of mole on this side is 0.015 equals to mass. We don't know the mass. Molar mass 36.5. Multiplying this together will give us the mass. 100 times 0.0075 will give us 0.75 gram. And what's 36.5 multiplied by 0.015 will give us, we can multiply mass here, will give us 0.5475 grams. These are the masses of these two substances that reacted. These are the masses of these two substances that did what? Reacted. Now, usually, if you want to get the number of moles, you are supposed to divide the mass divided by the molar mass. Class, I'm just taking you back. Because if I'm to solve this, I will not go back this far. I know what to do. But I'm trying to take you what? To take you back. If I want to solve this now, what I'm going to do now, class? This is 0.75 and this is 0.5475. These are their masses. To get their molar mass, to get the number of moles, this is where the mass, this is where the question usually starts from normally, class. If they were to ask this question, they will tell you that 0.75 gram can try and teach you how to determine the mixing reagent of CaCO3 reacted with 0.5475 gram of HCl, determine the limiting reagent. This is where it's supposed to start from, normally. Given that 0.75 gram of CaCO3 reacted with 0.5475 gram of HCl, determine the limiting reagent. Now, the first step in determining the limiting reagent is to, write down steps to determine the limiting reagent. 1. Determine the number of moles of each reactant. Number of moles of what? Determine the number of moles of each reactant. Determine the number of moles of each reactant. Step 1 to determine the limiting reagent. What is the limiting reagent again? The limiting reagent is the reactant that is first used up. Class, the limiting reagent must be on the left-hand side of the reaction. It cannot be on the right-hand side. The limiting reagent must be on the left-hand side of the what? Reaction. It cannot be on the what? Right-hand side. It must be on the left-hand side of the reaction. It's the reactant that is first used up. So it's between this and this. After determining number of moles of each reactant, step 2 is divide by their coefficient, divide by their what? Divide all through by their what? Coefficients. So how do we get the number of moles of each of these reactants? Number of moles is the mass given divided by the molar mass. Number of moles is mass over molar mass. Number of moles is what? Mass all over molar. So you're going to say 0.75. We're assuming that the question started from here. I'm not just taking this question for this question's sake. I'm using it to teach. Do you understand? So I'm reversing the question back to the original version of how to solve for limiting reagent. Usually they'll give you the mass. From the mass, you first get the number of moles. But class, this question has already bypassed the first page because they are giving the number of moles. But after getting the number of moles, the second step is now divide by their coefficient. Divide by their what? Coefficient. Now class, if I follow the first step again, 0.75 mass over molar mass. What is molar mass of this? 100. I will come back to 0.0075. And if I do this, follow the first step. The number of moles, mass all over molar mass of this. What is mass of this? 0.5475. Divided by molar mass, 36 point. The hydrogen is 1, chlorine is 35.5. That's 36 point. I will arrive back at this. I will arrive back at, just do it, 0.5475 divided by 36.5. You see that you have 0.015. You arrive back there. Are you seeing it? That's the first step. Now the second step now says divide by their coefficient. Divide by their what? Coefficient. Now, if you divide by their coefficient, coefficient is the number. What's coefficient? Coefficient is the number before the compound. 1 CaCO3 plus 2 HCl. So HCl, the coefficient of HCl is 2. The coefficient of CaCO3 is 1. But class, in the Jamb exam, you do not need to go back to the mass because I'm teaching. Because I'm what? Teaching. In the Jamb exam, they are happy to achieve the first step by giving the number of. But I'm telling you that in another question, they might not. I don't really want you to just cram what we are solving now. I'm not giving this question for us to just get it. I'm giving you to so you can be able to apply in your exam. whatever they bring on this topic, you can answer it. That's how we're teaching. If not, if it's just subjects that have been done since we're moved forward, we're teaching. So I can take, in this class, I can take 1 or 2 or 3 questions and dwell on it, teach everything about it so you can understand. So anyway, they bring it next time. Because one thing about Jamb, it's not like university level. University level can just bring the question like that, but Jamb can switch it, you understand? Can bring something else in that same, can still bring that topic, but not the same thing. To just switch it. So I want you to understand everything about the limiting radius. That's why I took you back from mole to mass. Okay, another question that they might say 0.75 gram of this reacted with 0.5475 gram of this. Determine the limiting reagent. Funny enough, that's not even the main question. The main question didn't even ask us to determine the limiting reagent, but for to solve the main question, you must first get the limiting reagent. Now divide after, so if the question came and they gave you moles, it means the question has already helped you to obey the first step, which is number of moles. But if we give you mass, it means you must obey the first step, find the number of moles on the mass. How do you find number of moles? Mass over molar mass. That is 0.75 divided by molar mass is 100. You saw how we got 100 for this guy. 40 plus carbon is 12. O3, 16 times 3, 48. 100 gram per. That's the molar mass. So you say mass over molar mass to land you back at the number of moles, which they gave us initially, right? Also, mass over molar mass to land you back at the number of moles. Step 2 now is to divide by their coefficient. The coefficient of CaCO3 is 1, divide by 1. Coefficient of HCl is 2, divide by 2. Now, so you see, dividing 0.015 divided by 2 will give you 0.0075. We give you what? We give you 0. What? Now, what is interesting about this question is that they now have the same number of mole. They now have what? The same number of what? Mole. Now, so what we are going to do, they now have the same number of moles, 0.0075, 0.075. In this case, when both thiazocarbonate and acid have the same number of mole, what do we do? Can I claim this? Yes. This is just the one we did before. What we do, how do they have the number of moles? Because this, they gave us 0.0075 and 0.00015. Based on this now, who is smaller? This is smaller than this, right? But class, after dividing with the stoichiometric coefficient of the reaction, we found out that they have the same number of what? Moles. Class, let us assume we're using this. Just watch it. Remember, we're looking for the volume of gas involved at STP. Now, this is a reaction stoichiometry question as well. But we'll say, let's assume CaCO3 is the one that is used up first. Watch. We're going to say, let 1 mole, from the balanced equation, 1 mole of CaCO3 gave what volume of CO2? Class, this is 1 mole of CO2. And 1 mole of the gas at STP. Molar volume of the gas at STP is 22.4 dm cubed. So we're going to say 1 mole of CaCO3 gave 22.4 dm cubed of CO2. Why is it 22.4? Because there's 1 mole of CO2, so it's 22.4. If it gave 2 moles of CO2, to be what? 2 times 22.4, which is what? 44.8. If it's 3 moles that was here, you say 3 times 22.4 because the int said molar volume of gas at STP is 22.4 dm. So for the balanced equation, 1 mole of CaCO3 gave 22.4 dm cubed. Now, the number of moles available is 0.0075 mole. We give what? X, we don't know. Class, we cross multiply. We're going to have x times 1 is x equals to 0.0075 multiplied by 22.4. What is 0.0075 multiplied by 22.4? What is 0.0075? We're going to have 0.168 dm cubed. 0. What? You know what's funny? Look at the options. Jamb. They converted from DN cube to what? CM cube. Our option is in CM cube. What will you now do? From DN cube to CM cube, what do? You multiply by 1,000. Multiply by what? And you're going to have 168 DN cube. We're going to have what? 168 DN cube. 168 what? DN cube.
Sorry, sir, is it DN or CM?
CM cube, yes, CM cube. It is already DN cube, sorry, my mistake. It's CM. Because this DN cube, we are going to CM cube, right? So 168 CM cube. But watch, class, I want to teach you something. Let us assume we use hydrochloric acid. And I'll tell you the one that is correct. Let us assume we use hydrochloric what? Acid. Hydrochloric acid would have been 2 moles of HCl. So in the balance equation, 2 moles of HCl give, from the balance equation, 2 moles of HCl give 22.4 dm cube of CO2. Right? You know how we got 22.4 dm cube, right? But for 1 mole of any gas, it's equivalent to 22.4 at STP. At ST is in the question. Molar volume of a gas at STP is 22.4 dm cube. This information here allows you to change 1 mole of any gas to 22.4 dm cube. Anytime you see 1 mole of any gas, it allows you to change to what? 22.4 dm. Now if you see 2 moles of any gas, you have to say 2 times 22 point. 3 moles of any gas, 3 times 22 point. So from the balance equation, we're using HCl. If HCl was the limiting reagent, 2 moles of HCl gave 1 mole of CO2, which is 22.4 dm cube, right? Now, how many moles of this is available? 0.0075 will give us what? X. We don't know. Will give us X, we don't know. So we cross multiply. 2 times X is 2X equals to 0.0075 times 22.4. 2 times X, 2X equals to 0.0075 times 22.4. Divide both sides by 2 to make X rate of the. So 0.0075 multiplied by 22.4 equals to 0.168. Now divided by what? 2. 0.168 divided by what? 2 will give us 0.084. This is the n, remember. To see n cube multiplied by 1 will give you 84. Because 1, 2, 3, right? 84 cm cube. You have anything like that in the option? No. We don't have 84 cm cube in the option. Class, but even if we did, I will still categorically tell you that my answer is 168 cm. Because class, limiting reagent produces the maximum amount of product that can be obtained. Maximum what? So it's clear that we have more volumes from this reactant than this reactant. So how do you know limiting reagent? If 2 of them have the same number of mole, after dividing by the coefficient, you check which of them produces the maximum amount of what? Reactant. Which of them produces the maximum amount of what? Reactant. So 168 saying, but this question has even saved us that conundrum. I thought if I was the one I wanted to make the question more wicked, I'll put 168 and 80 for now see what is then we choose. So volume of gas above at STP is 168. But they give us a small problem. They first put it in DN cube, right? Anything that does not have to convert from DN cube to CN cube will still have problem, but it's very simple. Just multiply by 1,000. Multiply by what? You see, if you are going to DN cube, divide by 1,000. Convert to DN cube, divide by 1,000. To multiply to CN cube, multiply by 1,000. Okay. We have the second question now. We have done 1, 3. Let's look at number 2. Okay, you're writing? Please, you have to be faster. You know, video. You can't wait for it to write. You have written it. Okay, I've written it. You can copy from it. Good. So let's take the last question for today. Please, it's going to be 4 p.m. in the evenings. We need quiet so we can study. Those that are going for the day of you that are in the physical class, it's going to be in the evenings after your activities so they can have time to attend the class. Are we together? To be in the evenings like this. Tomorrow is what? Tuesday. We also have Tuesday. We also have Wednesday. We're going to have class tomorrow, Tuesday by 4. We'll have class tomorrow by 4. Then we'll have Wednesday. I'll give you the timetable. We just need 4 days, 3-4 days of the week. So pick 3-4 days of the week. Now, can you remind me of the third question? The second question, actually. We did this one, the third one, right? What was the second question? Remember. Okay, the second question said the percentage of water of crystallization of Zn SO4.782. Class, this compound is an efflorescent compound. Is an efflorescent compounds, when exposed to the environment, to the atmosphere, they lose their water of crystallization. You can clearly see the 7H2. This is the water of crystallization. We have to calculate the percentage composition of the water of crystallization. Sulfur is 32, oxygen is 16, hydrogen is 1. We have to calculate the percentage composition of the water of crystallization. Class, first things first, to calculate the percentage of water in this compound, that's what they're asking us to find. It is going to be the mass. Class, formula for percentage composition. The formula for percentage what? Composition is mass of elements that you are looking for divided by total mass of the compound multiplied by 100%. Multiplied by what? 100%. Class, but this time around they say we should find for the water of crystallization. So it will be mass of water, total mass of water in the compound divided by total mass times 100%. Mass of water, we have 7H2O. Class, mass of water in this compound, mass of 7H2O. Class, for 1 H2O is 18 because hydrogen is 1. Follow me please. Hydrogen is what? 1. But we have 2 hydrogens, 1 times 2 plus oxygen is 16. 1 times 2 is 2, 2 plus 16 is what? 18. Class, the mass of 1 molecule of water is 18 grams. But if we have 7, that will be 7 times 18. 7 times what? 7 multiplied by 18 will give us 126 grams. So class, the total mass of water in this compound is 126 grams. Now let's find the total mass of the compound as a whole. So apart from this water, there's still zinc 65, there's still sulfur 32, and there's oxygen. Oxygen 16 times 4, oxygen is 16, right? Look at on this int, oxygen is 16, but we have 4, oxygen 16 times 4 gives us 60. Now 64 plus this 782, which is 126. Remember that 782 we did it here, 1, 2. So that would be 65 plus 32 plus 64 plus 126. We give us what? 287. 287 grams per mole. Just to confirm one more time. Yes, 287 multiplied by 100. So mass of water of crystallization divided by the total mass multiplied by 100%. That is 126 divided by 287. 126 divided by 287 is 0.439. Now times 100%. 0.439 times 100% is 43.9%. If you approximate, you should have 44. This 9 can cause an addition of 1 here, making it 44%. Do we have that in the option? Check the option I gave you. Is that 44%? Do we have it? Yes. Yes. So class, with these 3 questions, we have introduced our Jamb chemistry. As I said, this video, if you are watching the video to the end, you've tried, send us a DM to register for the Jamb class. It's a very serious class, as you can see. All our tools to record the class. In case you are staying far away, no matter the state you are staying, you can access the class and learn with us. So send us a DM so we can register you, because the next videos after now won't be posted for everybody. It will only be posted and accessible to our registered members. Work with us so we can help you. If you want to pay instrumentally, it's also allowed. If your full payment is not ready, you want to pay instrumentally, it's also allowed. If your full payment is ready, you just pay at once and you rest for the Jamb program. As I said, the fee is 30,000 naira per month. 30,000 naira per month for the fee. Because we're going to be teaching the courses: chemistry, your physics, your maths, your biology, and your English. So get ready. So send us a DM so that we can register you for the Jamb class. Thank you very much.